session of the day. Jason Myers will be talking to us about serverless architecture for powerful data pipelines. There'll be 5 minutes for questions at the end.
Hi, everyone. Good afternoon. Almost evening. My stomach is not adjusted to Pacific time, so I am starving. So I will make this as quick as I can because there are cookies somewhere in the world with my name on them. I wanted to give this talk. I work at this wonderful little company, Juice Analytics, and I wanted to share some things that I've done both working there and with some other clients that I work with on the side. You know, my original start with data pipelines goes back to my original dream. Originally, I thought I was going to be an analytical chemist, but then I saw the job markets for analytical chemists. There is not one. Click, there we go. So my original introduction to data pipelines was on one of these things. Anybody know what kind of machine that is? Cray, good guess. It's a convex mainframe from ancient times, the 90s. And I got an internship at the Air Force Base, and I spent all my time as a chemist running somebody else's experimental numbers through ETL pipelines and through data pipelines to perform calculations, that kind of thing, through these things. So my introduction to analytical chemistry as a job was to do computer science work. And traditional pipelines are often kicked off. Everything was scheduled. It was extremely complex and difficult to reason about because there were all these interdependencies about where the data came from and what we needed to do with it. And at that time, there weren't like globally shared libraries, so I had to go like find the one guy who wrote that script 6 years ago that did that thing for that one thing that no one remembers anymore. And no one knew how it worked. We just tried it, and the number looked right, so we went with it. And I know that I've loaded absolutely trash data via ETL and via data pipelines just because we didn't understand it and because we just trusted that something else worked. And this complexity makes it exceptionally difficult to scale, right? We would often kick things off and let them run for ages, hours, days, a week sometimes, depending on what we were doing. And the data sets would even change. By the time that we had the results back from one process, another experiment had occurred, and I needed to run something else. And quite frankly, it's just like this. Super stressed. I mean, when I was in high school, I had hair. I looked like Matthew McConaughey. This is what I got, okay? Old man screams at cloud is a real thing. But thankfully, it's gotten a lot better, right? Recently, we've had wonderful toolkits, things like Luigi and Airflow, AWS data pipelines that let us focus on the sources and the transformations that we want to do, some outputs and notifications, but they handle a lot of like the surrounding pieces for us, right? Airflow has nice scheduling, and Luigi has wonderful task definitions to build on top of, and those kind of things. So they've made it great, and they all had some way of kind of like handling what happened when something didn't execute properly, which is something that in our hand-built pipelines we didn't have, right? And those things are wonderful, but I'm still often needing some other component to help me. I need something to help me react to an event, to trigger it, instead of just a regular old cron job. And I need something to help me like scale out and handle more parallelization and those kind of things. Or sometimes I want to mix and match a streaming source in with the data that I'm working on. And I don't say any of these things to pick on those tools. Those authors have all made very responsible choices and very smart decisions about what their tools should be good at, and they left other things for the implementers. And for me, I like to fill these gaps with serverless. You should just scream this. I mean, there's a ridiculous amount of hype, right? You can go ahead and check mark on your unicorn hype cycle bingo card. You can go ahead and check off serverless if you haven't heard it 16 times today. But people are very hyped about it and very excited about it. And I think that's great, but I think it's important to kind of temper that with what that means. There's a lot of tools flying around about serverless, a lot of words being said, and then in practice, you see kind of the same examples kind of come up over and over again, right? We see a lot of video transcoding, we see a lot of maybe simple web serving or connecting something that used to be a standalone microservice in a container and moving it into a serverless architecture. But what does that even really mean in the context of a data pipeline, right? What we're really focused on is cloud functions, right? Wonderful little event-driven functions that we can just upload that very simple function, its code, and then don't really worry about what's executing it. I mean, clearly there's a server under there somewhere, but do we even really know that? Maybe there is, I don't know. It's not serverless, but clearly there's something that has to run it, right? And I like it because I don't have to worry about how they are running until I do, right? So if I do something in serverless, there's a good chance it's going to scale for me for quite a while as a cloud function before I have to actually think about what's going to occur. If it works the first time, it's going to work for a while, and then I can react to when it doesn't. I'll come back to that if it works the first time, because I think that's an important thing to bring up later. I kind of like that they feature automatic logging, permission-based execution. It makes working with them something that's very prescribed and auditable, right? Which is important as we start to think about what our data pipelines touch, particularly in the area of HIPAA and those kind of things, as we start to do analysis about like this collection of people has this disorder or this thing that we want to look at. We need to audit who's touched those and who could have possibly seen that stuff. That was a little difficult to do in some of the other tools, but by being able to control things, who can see and kick off things, we can do things in a very prescribed manner. And then my favorite part of it is everybody's kind of doing it. You have AWS Lambda, Google Cloud Functions, Azure Functions, so we can connect them things like Google's wonderful machine learning and container services, or Azure's beautiful machine learning APIs that they publish. And of course, Amazon has a tool for everything, right? And all three of them work quite well. They all have their own little quirks and their own little feature sets that are different. And we're going to focus mostly on Lambda for this talk. Basically, because it's been around for the longest, we have many Python tools that make it very simple to use and get started. Lambda supports current Python, legacy Python, that's 2.7 something. I'm not sure what the exact version of it is at this time. Node, C#, and Java. So you got quite a wide range of languages that you can mess with. And then they've gone beyond that, and people have made shims. So we can even run things like Golang or NIM or some other things that are not quote-unquote supported by Amazon, but people have made ways to run them. All right, so let's talk about a very simple serverless pipeline example. The easiest place to start is we get a file upload, right? The client may send this to us on a regular basis, or we may just let them upload it whenever. Well, normally if this was a traditional pipeline, I would have a scheduled job that would run an hour after they uploaded the file, right? And then I would try to like stagger all those out throughout the day so they wouldn't overlap or cause any problems. But here we can kind of get away with this. In the Amazon world, when we upload a file to an S3 bucket, we have an option to have it actually fire an event. And that event can have a wide array of topics. In particular, I can send it directly to one of these Lambda Cloud Functions. And in the event, I can decide what needs to happen to this file. Does it need to be compared to some existing data that we currently have? Do I need to send it to a different place to be processed? Does it need to be processed securely because it contains, special information, that kind of stuff? And the way that we can kind of break this event coming in from the actual processing of things is to use a queue. So here's an example with a small SQS queue in place to hold the events that are coming in until we're ready to react to them or do something with them. This queue can then feed another function, which is great because we can decide at this point, the handler knows the file's name. It may know metadata about it that we've appended to it, but it doesn't actually do anything to it. We can then hand that off to a separate function that performs the appropriate handling of that file. For one thing, Lambda is not HIPAA compliant. So we might, if it's a HIPAA file or a PCI protected file, we might hand that off to a process that can run in a protected manner. And we have an opportunity to do that at the event handler and then ultimately based on how we pull the things from the queue. Finally, we can lay in, let's skip 2 slides, sorry. Finally, we can lay in a Lambda function to write the data to a data warehouse. In this case, we might be using Redshift. And then alternately, we can add a transform function outside of this normal path so that if we need to do something like correct an error in data or run a particular type of the data through a classifier or something like that, we can do that on the outside. And one of the great things about this is because this is reacting to an event and this is just a function, we can have multiple invocations of that function, right? Amazon by default allows about 1,000, I think it is 1,000 per account, but they're extremely flexible and you can request to go far, far beyond that. Let's look at some tools that kind of go with this, but you can kind of get the flow of what happens here. We have an event that starts something, we lay that event somewhere where we can pick it up in a second when we're ready. Maybe we're waiting for some, multiple pieces of data to arrive, and then we have a couple of different pathways to go out of the file reader before we ultimately put it into a data warehouse. In serverless in Python, we have a bunch of great choices. We have the Zappa framework, we have Apex, Chalice, and of course there is a serverless framework just to make it even more confusing. We must add serverless to everything, just like randomly throughout this presentation I will say serverless, and it will feel like it goes right, but it shouldn't be there. I tend to use the Zappa if I'm going to be doing web apps or web APIs or some kind of proxying type thing, but when I'm building cloud functions for data pipelines, I really like to use Apex. This isn't a slam to any of the other tools, it's just personal preference. The thing that I like about Apex is it, out of the box, easily supports handling multiple environments. It allows you to also have your function deployment kind of automatic. They've got a very simple command that wraps up some of the complexities that we're going to talk about in a second with deploying a function like this. And then finally, they actually allow you to have infrastructure as code directly under the same CLI that you would use to deploy your functions or to even build your functions, which I think is wonderful. And Terraform is the way that they expose that to, which is a very popular way to manage resources in Amazon, Google Cloud, and Azure. I really like us kind of having all of it in one tool. So let's look at a typical project structure of an Apex project. So we have our function. So in this case, I just have the listener here. This would be the S3 event handler, just for us to have something to talk about. And I can have a collection of those. Basically, every directory I create in the functions directory there can be another step in my pipeline. And it can perform anything that I've put within that code, any code that I've put within that directory. So in the next step, we have our actual infrastructure code. So here we can declare anything in Terraform that we need to have created. Maybe we need specific permissions within Amazon, or we need the ability to write to a DynamoDB table, or we need the ability to send an email from that. We can grant all those permissions in the same repo using the same tool here. And then finally, we have the actual environment configuration for each environment they're going to be working on. And again, because this is all in one tool, all connected, it gets really quick to be able to define commonality between those environments and not have to write out custom scripts for every single one, which is wonderful. Here's an example of what the package JSON looks like that declares the environment. Basically, you tell it what the name of the function is. You can give it a short description if you like. You explain to it which language you're going to be using to run on Lambda, how much memory, timeout, any roles that it might need, and then in the environment block, you can give it environment variables, those kind of things. Typical things that you would feed when you're doing a deployment. Let's look at a simple kind of trivial example here for an S3 event handler. So the first and most critical part is actually this handle function down here at the bottom. Every event handler, Lambda, that you have is going to have a function that looks just like this. It's basically going to get an event and a context. So the event is what actually got sent. So that would be the message from S3 that tells you what files you got, or the message from anything else that occurred in your cloud. Maybe you have CloudWatch alerts that trigger events. That comes in under the event, and then the context is any additional data that you or your framework that you're using, or sometimes Amazon needs to add on to that event for it to make it relevant, right? One of the cases where we use this is we use the context to decide whether that event needs to be processed, can be processed in Lambda, or whether we need to sub this out to a Docker process, for example, where we can run it on a dedicated instance, although that's not required as of last week, but where previously we could run it on a dedicated instance. Looking at that event in a little more detail, we often want to get where the file is stored, so we want to get the bucket and, of course, its key name. And after the handle method, this is the way that we process the events. And we normally break these out. We try to keep our handles very clean, very simple, and very explicit in what they're going to do, because it's easy, because it's all going to be in a file most times. It's easy to make a pretty complex file that's hard to read, so we try to keep our handle methods very simple. So this parses the event, and here you can see S3 sends those in the structure that's kind of listed there. You're always going to get those events in Apex as JSON format, or basically looks like a dictionary to you by the time you get it. And then this is the rest of the handle function where we're operating on the values of that. And then ultimately here we're going to publish that to our SQSQ. I mentioned earlier that we can connect in our infrastructure code to this to lay out what we might need. And a good example of that is an IAM role to grab those logs, or an IAM role to allow access to a particular database. So Here's an example of what that looks like. I'm not going to go through this in detail, but I wanted to show you that it's a few steps to declare, but then you have repeatable, rerunnable code that will make the environment the same every time you run a deploy of this code. In our case, we have multiple accounts, one for dev, one for staging, one for production, and we can replay this exact same code, get the exact same setup, the exact same names, permissions consistently without having to worry about it. And if someone makes a change, it's easy to see that roll through the environments without having to worry about checking that back against some random file that's not in configuration or that someone manually adjusted. Here's the remainder steps of that for the assume role to let Lambda take it, and then attaching that policy. So once we have our function and we have our infrastructure code, we can then use these 3 commands to get everything deployed. So the very first step, the Apex deploy there, is going to go out and create our Lambda package. It's going to go out to AWS and make sure all the initial permissions are ready for you to publish a package. And then it'll publish your Lambda function to the cloud. Then the next command there, the Apex infra plan, is a way for you to see if I run this kind of destructive apply command with the infrastructure that I coded, what is going to be the result of that? So it'll print out a nice list of this is what's going to change, this is what you're going to delete, this is what you're going to add. And then finally, the infrastructure apply will actually apply those changes to your infrastructure if you've added new permissions or anything like that. And I think it's nice to have just these 3 simple commands on a very repeatable basis. I work with a lot of people who are business analysts for a living, and so we've wrapped this in another CLI so that they can run one command and it does the right thing for them. If the plan looks right, it just executes it, which is great. Now, I know you're probably thinking, what about all those other functions you had on your screen? You had a data reader, a data writer. I have examples of those in a repo that you can take a look at. I didn't want to go through them line by line because they're all basically the same. They get an event, they perform some processing on it like you would do in any other function, and then they drop an output somewhere. But there are some caveats that I didn't show in my trivial example there. I think that's the case with everybody, right? Like, oh, look, here's the super simple thing. Draw these 2 legs of this horse, and then suddenly, boom, here's a beautiful stallion that you drew a picture of. So continuing in that font tradition. I'm just kidding. The people who made Zappa have made this wonderful thing called Lambda packages. And what's great about this is they went through and they've grabbed a bunch of libraries that have to be compiled and made them super simple to install for use in Lambda. It turns out that you can also reuse these in Azure functions, and some of them even work in Google Cloud Functions with little effort as well. And the reason why this is important is there's nothing that you're pip installing requirements into directly, right? When you push a package to Lambda, it's a zip file of your code, and then any other libraries that it's dependent on need to be at that same top level, and they've got to go in one package. So they've made a very simple collection of pre-compiled things that are compiled to run exactly on the system that Lambda is set up to run as. There's no worrying about, did I get the right will, or did I, will NumPy accidentally not detect the will and try to rebuild it from scratch, that kind of thing. You don't want to be paying for that in Lambda time. So they've packaged all that up for you. And Apex is also pretty smart to help you handle dependencies as well. If you have something that you do need, like request, for example, you can create a requirements.txt file and add this in as a hook. So what this is every time you run that deploy command, the first step of deploy is build. It will go through and pip install locally. That's what the dot at the end, it says pip install this in this current directory. So it will build that, install everything in the current directory, make the right zip, make sure that all your imports work, and then it will push it up just like it would normally. If you've tried to build a Lambda function by hand, it can be extremely complex to get everything in the right place. And they've kind of taken out of that. And while this is a good start, you can always stack Google Overflow all the things because many people have run into the same problems you're going to encounter when you try to do these deploys. So you'll be able to look for other solutions to problems. Before we had Lambda packages, we needed to install pandas. So you cannot compile pandas on a Mac and get it to run on in a Lambda function. It also turns out that I couldn't compile it on Ubuntu and get it to run on a Lambda function at the time. I actually had to grab a copy of AWS Linux, build it, and then push it that way. Thankfully now there's the mini Linux will, and that's fixed that up a lot. But if you run into something odd, there's a good chance somebody else has ran into it as well, and you'll be able to find it online. Some things I want to leave you to think about before we look at a bigger example are consider that your functions need to be atomic, and I'm not going to go into the CS definition of atomic here because I don't want to explode my own brain because there's lots of math, but in general it basically means that you can run this function in isolation from the rest of a larger piece, and that it does a whole thing on its own, right? So it's going to do a finite thing to completion. It either works or it doesn't work. When it doesn't work, it's explicit that it doesn't work. When it works, it's good. And it also means that I can run multiple of those things side by side, and they won't interfere with one another, okay? Finally, that second part is we need our functions to be idempotent. I say that hesitancy because I'm from Tennessee, so we like to slur our words a bit. And again, skipping the CS view, it really means that if I run the same function twice on the same piece of data, I will get the exact same result, right? This is not always a thing, right? Often our functions have side effects or they do something mutable. Let me give you a good example of this. How many of you commonly in your function code will just set something equal to an empty list and just move on with life, right? I've done that a bunch. The problem is that Lambda functions don't necessarily go to sleep or stop, like they stop running your code, but if they get invoked again, they might be hot, and that list that you created as just an empty list would still have all the elements from the previous run in it. So you have to start thinking about making these things like they run, and if they ran again, make sure they don't collide. If you're incrementing a value, make sure you've already checked to make sure that we didn't increment the value for the same reason, that kind of stuff. And clouds are awesome, right? Because in Amazon and Google and Azure, they all promise one thing. Every event will fire at least once. So that means on bad days when the cloud is upset and Grumpy Bear is around, you will get that event at least 4 times, maybe 5. And in our best day, we got it 17 one time in less than a second. That was a good day. Cloud functions have a bunch of limitations, and so this leads me into my final example that I want to talk about. And this is mixing what you currently have and adding some serverless onto it in places where it makes sense. Another example of a place to use this is when you're dealing with compliance information that you simply can't process in Lambda. Often you may have an existing pipeline that you want to leverage. No one wants to go back and touch that ETL that's been in production for 4 years, and that guy is no longer there, or that lady is no longer there. We don't want to go back and touch that again. Dark magic occurs. So we can put some Moby on it, Docker on it, I don't know. We're in Portland, so we put a bird on it, right? Either way, we can containerize that pipeline and use something like ECS to run those containers on maybe dedicated instances that we need them or whatever. And what's great about this is once we define a task definition for running this, then we can use anything to trigger it, right? We can put a Lambda function that can invoke that task definition and kick off our pipeline, right? It can go get the right files, we can send it data, all of those wonderful things. What's great about this is it allows us to do this in reaction to something like that S3 file upload, right? Or in Amazon terms, there's a CloudWatch ability to do scheduled events. It's like cron tab in the cloud for people my age. And it's great because it'll run, it'll do all the things, put the data in our data warehouse. However, containers have this really nasty thing, and it gets even nastier when it's not local and you can't watch it. And that is, they run out of memory, and they just die, right? So even if you use a tool like Sentry or something like that, when it dies, because it ran out of memory, Sentry doesn't know. It never got called, right? And that's the same case for like when Pandas is having one of those weird compile things and it runs out of that, you get that Python garbage collection error. You've gotten that with Pandas before? When one of those things happens, you're not going to get a report that it died, right? And so we need a way to watch it. Thankfully, all of the cloud providers, and I'm going to pick on Amazon because that's what we're using here, they have a method for dealing with this. They can stream the events that occur within their container clusters. Kubernetes and Google Container Cloud have a similar setup as well. And the ECS will publish events to a Kinesis stream so that we can consume them later, right? So now we can have a stream processing Lambda that watches those and makes telemetry decisions about like this is running too long, it's running too short, it didn't finish, that kind of stuff. And then, of course, Nuth forbid if we don't send a Slack or a PagerDuty notification, so we'll have to add another Lambda on for this. And the beautiful thing about this is as each one of these things occurs, it can run another invocation of this, right? So you can have hundreds of these things running at a time in a relatively simple structure. Then any time that a container explodes because it runs out of memory, ECS will send a stop event, and then our stream processing Lambda will see the stop event and react accordingly. It'll send a notification on Slack that we'll all ignore. So last thought. It's very important, like with all ETL, to continue to consider the workload and the phases, right? Lambda can only run a function for 5 minutes, right? So if you need something that's going to exceed that, if your chunk of work is going to exceed that time, you've got to think differently. I worked very hard. I went into the woods of Tennessee, and my coworkers will get a chuckle out of that because I really did. And I tried to come up with some good example to like show you a number. This is X faster, right? And so I did this contrived example, and then I was like, I cannot even explain why this is important. So I thought I'd share with you a more colloquial example and then give you the reason why this. I've seen this improve weather data stream processing by 14%. I've seen it improve, or 14 times, I'm sorry. I've seen it improve cloud telemetry performance by 9x, but I've also seen it slow down existing pipelines, right? Cut almost a quarter of their speed out. And the reason for that is some things just don't work well, right? If you want to do individual processing on 100 million records on Lambda, you're going to have to use a lot of queues. Queues add latency, those kind of things that you might not be getting. And that's the case where we mix in those Docker containers to eliminate that. Sorry, I'm losing my voice. So that reduction, into that came with greater visibility, though, right? Because we can still have all those watcher lambdas and those things paying attention to what's going on and reacting to those events. So with all of that said, that was a mouthful. Any questions?
We've got about 5 minutes for questions if you want to come up to the microphones.
Hi, I was wondering if you could talk a little bit about testing and if there are like tools like along with these frameworks.
Sure. So you can use standard PyTest for testing your cloud functions, but if you want to test what they run like, there's actually a Docker container that simulates being able to run Lambda functions. I've seen one for Google Cloud Functions as well, but not one for Azure Functions. So there's certainly a way to do that test. There's a Docker container for it. It's literally like Docker-Lambda.
Yeah, I guess a follow-up, are there standard like libraries for mocks of like the sorts of context and events that you receive in the Lambdas?
So depending on what I'm doing, if I'm using like requests, I'll use something like Betamax, or there's a mock tool for Bodo. Is it Modo? I think it's called Modo, actually, that mocks all of the AWS servers like services like SQS, SES. Pretty sure that's what it's called. That's right. Awesome. Sorry. Anything else? Thank you very much for your time. Top of and those kind of things. So they've made it great. And they all had some way of kind of like handling what happened when something didn't execute properly, which is something that in our hand-built pipelines we didn't have, right? And those things are wonderful, but I'm still often needing some other component to help me. I need something to help me react to an event, to trigger it, instead of just a regular old cron job. And I need something to help me like scale out and handle more parallelization and those kind of things. Or sometimes I want to mix and match a streaming source in with the data that I'm working on. And I don't say any of these things to pick on those tools. Those authors have all made very responsible choices and very smart decisions about what their tools should be good at, and they left other things for the implementers. And for me, I like to fill these gaps with serverless. Traditional pipelines are often kicked off. Everything was scheduled. It was extremely complex and difficult to reason about because there were all these interdependencies about where the data came from and what we needed to do with it. And at that time, there weren't like globally shared libraries, so I had to go like find the one guy who wrote that script 6 years ago that did that thing for that one thing that no one remembers anymore. And no one knew how it worked. We just tried it, and the number looked right, so we went with it. And I know that I've loaded absolutely trash data via ETL and via data pipelines just because we didn't understand it and because we just trusted that something else worked. And this complexity makes it exceptionally difficult to scale, right? We would often kick things off and let them run for ages, hours, days, a week sometimes, depending on what we were doing. And the data sets would even change by the time analytical chemist, but then I saw the job markets for analytical chemists, There is not one. Click, there we go. So my original introduction to data pipelines was on one of these things. Anybody know what kind of machine that is? Cray, good guess. It's a convex mainframe from ancient times, the 90s. And I got an internship at the Air Force Base, and I spent all my time as a chemist running somebody else's experimental numbers through ETL pipelines and through data pipelines to perform calculations, that kind of thing, through these things. So my introduction to analytical chemistry as a job was to do computer science work. And traditionally, that we had the results back from one process, another experiment had occurred, and I needed to run something else. And quite frankly, it's just like this. Super stressed. I mean, when I was in high school, I had hair. I looked like Matthew McConaughey. This is what I got. Okay? Old man screams at cloud is a real thing. But thankfully, it's gotten a lot better, right? Recently, we've had wonderful toolkits, things like Luigi and Airflow, AWS data pipelines that let us focus on the sources and the transformations that we want to do, some outputs and notifications, but they handle a lot of like the surrounding pieces for us, right? Airflow has nice scheduling, and Luigi has wonderful task definitions to build on top.
Session of the day, Jason Myers will be talking to us about serverless architecture for powerful data pipelines. There'll be 5 minutes for questions at the end.
Hi, everyone. Good afternoon. Almost evening. My stomach is not adjusted to Pacific time, so I am starving. So I will make this as quick as I can because there are cookies somewhere in the world with my name on them. I wanted to give this talk. I work at this wonderful little company, Juice Analytics, and I wanted to share some things that I've done both working there and with some other clients that I work with on the side. You know, my original start with data pipelines goes back to my original dream. Originally, I thought I was going to be an